Hi everyone, my name is Zachary Tomlinson. I graduate from the University of Oklahoma in December 2019 with a bachelor's degree in geology. I'm going to talk about earthquake safety and how that is portrayed in the 2015 film San Andreas and the 2009 film titled 2012. If you live in the US, in places other than the West Coast or Alaska, you'll probably get most of your knowledge about earthquakes from the media. The goals of this video are first to fix wrong media ideas about earthquakes and earthquake safety for those of you who have had little or no personal experience with them, and secondly, to give those people a response plan in case of an earthquake. With regard to that response plan, I will cover basic earthquake safety information and what you should expect to see during the earthquake. You should have a good response plan in place if you visit an area with high earthquake risk, because you will probably not have warning before an earthquake happens. This brings me to my first point. Scientists cannot forecast earthquakes like the weather, so people need to know how to respond to them ahead of time. This is often misrepresented in the media. Many films follow a scientist who has predicted that a major earthquake will occur soon and must get the government to listen. For example, the 2015 movie San Andreas follows that plot. And in the movie, scientists predict that the major earthquakes are coming in a few minutes or hours based on magnetic pulse rates, as shown in the clip here.
It's incredible. This is the third mini quake since we've been here. And the magnetic pulse rate has increased before each one of them.
We got a pattern, my friend.
That was a 2.2. Our model's predictive.
We got it right, man. Finally.
Yep, we sure did.
Shit.
What's wrong?
The pulse rates are spiking again. They're huge.
Are you serious? Jim?
We're about to have a major quake.
It jumped to a 7.1. Jesus, Kim, get the hell out of there!
So I did recently read an article about how the Earth's local magnetic field pulsed at low frequency before some earthquakes pretty recently, but that doesn't mean that we can predict earthquakes now. Here's the science behind earthquake prediction. True earthquake predictions calculate the probability that seismic events will occur in the next period of time. Usually it's pretty long periods of time, like 100 years, 10,000 years, etc., based on the history of earthquakes there. This is also how earthquake risk is calculated. Media does not portray earthquake prediction like this. Even scientists do a pretty poor job sometimes at portraying earthquake prediction to the public sometimes. For example, Giampaolo Giuliani issued warnings about an upcoming earthquake in Italy based on radon emissions and claims to have predicted their 2009 earthquake. These predictions are misleading though, because the warning factors don't always occur before every earthquake, and they can't be applied to multiple locations. Here's the thought process for scientists doing work on this. So first, scientists studying a fault see some strange data. For example, weird radon emissions or magnetic pulses. So then the earthquake happens, and the scientist claims to have predicted it based on the weird data that they found, and then maybe they publish a paper. So their thought process here is that the weird results showed that an earthquake was coming. That's not really a very good thought process, because the weird results that scientists report aren't really causing the earthquake. The only thing that causes the earthquake is the release of built-up stress. It's certainly not radon gas or some magnetic thing. So even though the weird results occur and make scientists suspect that an earthquake is about to happen, other earthquakes might not have the same warning factors, because those factors aren't required for the earthquake to occur. Therefore, the best that we can do as scientists is a statistical relationship for prediction. So some takeaways from this. There are usually no advanced warnings and no evacuations like in movies, such as San Andreas, before earthquakes. If you live in or are visiting an area that is at high risk for large earthquakes, you must have a plan in place for how to react when they occur. You can look at USGS earthquake hazard maps like the one shown here on the right to determine if you are visiting or living in an area with high earthquake risk. They are pretty easy to find on Google, and you can get more zoomed in versions as well. So far we've established that you need to have a plan for earthquakes. Next we're going to talk about what that plan should look like. How to respond to an earthquake. The seismologist from San Andreas actually does a very good job portraying this in the movie. Let's watch a clip of it now.
Under the table!
So they stay away from the door frame, they get under some desks, and they hold on. So notice that the professor says drop cover and hold on during the clip. So drop cover and hold on actually comes directly from the U.S. Department of Homeland Security and their official page on earthquakes. The red poster shown at the end of the clip is also from that official website, which is part of the diagram that's shown to the right here. So the idea is to protect your head, neck, and vital organs as much as possible from falling debris. If you cannot find a table, desk, or anything else to cover your head, find an interior wall and cover your head and neck with your arms. Door frames aren't encouraged, which I didn't really realize until recently. So you should not try to leave a building during an earthquake due to risk of being hit or crushed by debris. If you are already outside, don't attempt to go inside. Now let's look at another portrayal of earthquake safety. The 2009 movie, titled 2012, does not depict how to respond to earthquakes as well as San Andreas does. Let's watch it here and discuss what they do wrong.
It seems to me that the worst is over.
Alright, so first they get under the table. That's good. She's right. See, if that had been a second later, that debris would have crushed them, which is why they should have stayed under the table. Okay, so those of you who have watched 2012 might remember that right after this clip, a chasm opens up and destroys the house, plus most of California. Drop cover and hold on, it is true, will not save you from that. So giant chasms like these are very commonly shown with earthquakes in the media, even though they aren't very accurate. Both San Andreas and 2012 show impossible chasms opening up in California. Let's look at the San Andreas portrayal right now. So you have big, giant, bottomless chasm, pretty characteristic.
San Andreas fault.
Alright, so that's that one. Now let's get a better look at the giant chasms in 2012.
This is coming in live from Coachella Valley out near Joshua Tree, that huge canyon. It wasn't there this morning. And 400 miles further north, White Reyes, same thing.
San Andreas fault is shifting.
Yes, and all major sister faults in the Bay Area.
Gordon, go! Go, Gordon, go! We're not there yet. Gordon, take off!
Punch it!
I have to get to 85 knots.
80's good.
All right, screw it. Here we go.
What's that? Okay, we're up.
So it is true that drop, cover, and hold on would not save you from something like that, but in reality most earthquakes don't open huge chasms in the ground. So plate tectonics, which is the motion of Earth's lithospheric plates, applies different types of stress to the crust based on the directions that the plates are moving. Rifts or chasms through solid rock can only form under tensional stress when the plates are moving in opposite directions, like in East Africa or the Basin and Range Province in the southwest US. Major earthquakes are uncommon in these areas because there's no easy way to build up stress because the rocks are spreading apart. The largest reported earthquake in East Africa was a magnitude 7. It's not a small earthquake by any means, but it's nowhere near the magnitude 9 ones that are found in other areas of the world. When fissures do open during earthquakes in areas that aren't under tensional stress, they are usually just through the soil or unconsolidated sediment. And that happens when earthquakes trigger landslides or slumps in steep places. So those ones stay pretty small. So let's look at the perfect storm conditions to make fissures, or chasms, in East Africa. The yellow arrows in this map show how East Africa is splitting off the rest of Africa, creating that tension in the crust. And that can create chasms as shown here. So this was from a news report in Kenya, and it happened last year. So the maximum depth from this chasm is about 50 feet. So even with perfect conditions, movies drastically exaggerate the depth. Because remember, the movies showed it pretty much bottomless chasms. And again, since these areas are under tension, well, there's not a lot of stress building up to cause earthquakes. So in summary, small chasms can open due to soil movement during earthquakes. But they certainly won't engulf a house, let alone a city. Larger ones require the proper stress fields and are still much smaller than in the movies. Now let's look specifically at stress fields in California and why big chasms can't open up in Los Angeles. So the lines with the triangles are subduction zones, which is where the Pacific plate is colliding with North America and getting pulled down into the mantle. So as you can see, they're mostly underwater, they're off the coast. The coast there is the thin black line, where the thicker black lines are those subduction zones. So that's compressional stress, so no chasms can form there. Now we have those red zones. So the red zones are spreading centers, and those are areas under tension. Most of them are off land, but there are a couple that aren't too far from San Diego, and those could possibly produce some chasms. Not huge, but possibly. I haven't heard any reports about that, though. Lastly, we have the San Andreas Fault, which is a transform boundary. And these transform boundaries can produce either compressional or tensional stress, depending on the shape and direction of the fault. Near Los Angeles, it produces compressional stress. So huge chasms aren't possible. And this is why. So essentially, the motion of the plate components smashes the rock against that curve in the fault. And that's right where Los Angeles is, which produces compression. If the motion was in the other direction, there would be extensional stress there instead. So the only kind of chasms Los Angeles would expect are the small ones that go through the soil. In addition to large chasms, movies usually show tsunamis right after the earthquakes. Now, you should take precautions against tsunamis if EAS, which is the early alert system, tells you to do so, or if you see the warning signs of tsunamis, because they are possible along the coast. Despite what is shown from this clip from San Andreas, an earthquake on the transform fault cannot create a tsunami because San Andreas Fault is above water, and then also there needs to be some displacement of the crust. But we'll still watch it. The water receding like that is a sign of a tsunami.
What's happening?
We gotta go. Water being pulled out like that's a tsunami. We gotta get out of the bay now.
Ray?
I see it! Alright, hold on! We gotta get over it before it crests!
So remember, in this movie, the San Andreas Fault has earthquakes, which again is on land, can't produce tsunamis. So here's the science behind tsunamis. There are many causes. Earthquake-induced tsunamis occur when an underwater earthquake in a subduction zone causes parts of the ocean floor to suddenly move and displace water, as you can see in this animation from the Australian government. So the plate on the right is subducting down, which is causing the plate on the left to go up and produce stress, and then it springs back up, displaces water, in a tsunami. So there are subduction zones off the coast of California, so tsunamis are technically possible from earthquakes there. But the San Andreas Fault is not a subduction zone and is not underwater, so it can't produce anything. There's also usually at least a small warning before the waves hit land, depending on where the origin point of the earthquake is. Most of the large tsunamis that hit the US actually come from other sides of its neighboring ocean basins, which gives ample time for warning. So the warning signs in San Andreas are correct, where the water level goes down suddenly. So if you feel or hear about an underwater earthquake and you live near the coast, look for those signs and listen to the early alert system because tsunamis are technically possible. They're not going to be as big as which was shown there, but they're possible. Now let's look at the 2012 rendition of tsunamis. Some of the tsunamis in the movie could have been caused by earthquakes at locations in the film, such as the tsunami near Japan in this clip.
Pull up the Japanese seaboard. cruise ship out here. But I guess you already knew that, huh?
Sir, we recorded 2 underwater quakes at 7.9 and 8.2.
So that lower earthquake epicenter isn't really very likely because there's no plate boundary there. But the top one is accurate, and an earthquake there could potentially cause a tsunami like this because it is underwater and it's along the subduction zone. So putting all this together, let's talk about your earthquake response plan. If you feel the ground start to shake, you're going to want to drop underneath a table, desk, or other solid object. Cover your head and neck, and then hold on and wait for the shaking to stop. No giant chaos here will appear to destroy everything, so do not try to leave. And then lastly, tune into a radio, TV, or cell phone if you are on the coast to determine tsunami risk, ASAP. And again, just to reiterate, if the earthquake happened on the San Andreas Fault, there is no risk of tsunami. So here's my work cited. The first source is where I got the USGS earthquake hazard map from. The second source is the U.S. Department of Homeland Security website on earthquake safety. The third source covers the story about the fissure in Kenya. And the last source is the site where I got the tsunami animation. All of the links are posted in the description, so I encourage you to check it out for more information. I hope you found this useful, and thank you for watching.